Here is a question that kept me awake for many nights. It is one of the deepest puzzles in all of physics. Why can you remember yesterday, but not tomorrow? At first, this sounds trivial. Of course, you cannot remember tomorrow. Tomorrow has not happened yet. But here is the strange part. The laws of physics do not care about the difference between yesterday and tomorrow. The equations that describe how particles move work perfectly well forward in time and backward in time. There is no arrow written into them, no sign that says this way to the future. And yet our lives move in only one direction, from past to future, with no return ticket. By the end of this talk, you will understand why eggs never unbreak, why ice melts in your drink, but your drink never freezes by itself, and why, at the deepest level, this remains one of the greatest unsolved mysteries in physics. Let us start with something ordinary. You wake up in the morning. You make yourself a cup of hot coffee. You pour in some cold milk. What happens? The coffee and milk mix together. You get warm coffee with milk. That feels completely normal. Now ask yourself this. Have you ever seen the opposite happen? Have you ever seen lukewarm coffee suddenly separate into hot black coffee and a floating blob of cold milk? Of course not. If you saw that, you would think something was wrong. But here is the puzzle. Every molecule in that cup obeys the same physical laws. Those laws work just as well in reverse. If you filmed every molecule and ran the movie backward, every collision would still follow the rules of physics. So why does the milk always mix, but never unmix? This question haunted a physicist named Ludwig Boltzmann in the 19th century. Boltzmann realized something profound. The answer is not about what is possible. It is about what is probable. Imagine a box with 100 balls inside. 50 are red, 50 are blue. You shake the box. What do you expect to see? A mixed jumble of red and blue. Why? Because there are incredibly many ways for the balls to be mixed, but only a few ways for them to be perfectly sorted. A perfectly ordered arrangement is not forbidden. It is just extremely unlikely. Now replace the balls with the molecules in a cup of coffee, not 100, not 1,000, but trillions upon trillions. The number of mixed arrangements compared to unmixed ones is unimaginably large. This is what we call entropy. Entropy is a measure of how many microscopic arrangements correspond to what you see at the macroscopic level. High entropy means many possible arrangements. Low entropy means very few. Boltzmann showed that systems naturally move from low entropy to high entropy, not because the laws of physics force them to, but because there are so many more high entropy states to wander into. Think of a bottle of perfume opened in one corner of a room. The smell spreads everywhere. No force pushes it outward. The molecules simply move randomly, and random motion almost always leads from order to disorder. That is entropy increasing. So Boltzmann's answer to the arrow of time is this. The past had lower entropy than the future. The universe began in an extraordinarily low entropy state, and everything since then has been running downhill, from unlikely to likely, from ordered to disordered. That downhill flow is what we experience as time. But this raises a deeper problem. If the laws of physics are time-symmetric, then why does entropy increase toward the future and not toward the past? Why was entropy lower yesterday? Boltzmann's answer is still the best we have. We simply accept that the universe started in a very special low entropy condition. This idea is called the past hypothesis. The arrow of time does not come from the laws themselves. It comes from the initial conditions of the universe, from the beginning. Think about an egg falling off a table. It hits the floor and breaks. That makes sense. Now run the movie backward. The broken egg pieces leap up, assemble perfectly, and land on the table. That looks impossible, but it does not violate any physical law. What makes it absurd is not the laws. It is the precision required. Every molecule would need exactly the right position and velocity. Such a state is not forbidden. It is just fantastically unlikely. This idea appears again in electromagnetism. The equations of light allow waves that move forward in time, and also waves that move backward in time. In practice, we only observe waves moving forward, not because the backward ones are illegal, but because of how matter is arranged in the universe. Once again, the difference comes from boundary conditions. The past is not the same as the future. Now consider the psychological arrow of time. You remember breakfast this morning. You do not remember dinner tomorrow. Why? Because memories are physical records. To create a memory, energy must be used. Heat is produced. Entropy increases. Memory formation requires an entropy gradient. The past had lower entropy. The future has higher entropy. That is why memories point backward. The psychological arrow follows the thermodynamic arrow. So we return to the biggest question of all. Why did the universe begin in such a low entropy state? We do not know. Some ideas involve cosmic inflation. Others involve a multiverse. Some suggest a cosmic bounce. None are confirmed. This question remains open. Here is the key insight. The laws of physics are like a road that goes both ways. They do not tell you which direction to walk. The arrow of time comes from the starting point, from the Big Bang. Time flows forward because the universe began in a special state. Entropy increases. Eggs break, ice melts, memories form, and every moment of your life is carried along by that same cosmic process. We do not fully understand why the universe began this way, and that is not a failure, that is the frontier. If you found this fascinating, let me know. What other deep questions about time would you like to explore? The arrow of time is written into every memory you have ever made, and we are still learning how to read it. Before you leave, let me ask you something personal. Right now, this moment will never happen again. Not for you, not for the universe. Every second that passes increases entropy. Every memory you make is written in a direction you can't reverse. That's what makes time feel real. So think about what stayed with you from this video. Was it the idea that the laws of physics don't care about past or future? That the arrow of time comes from probability, not force? Or that memory itself only works because the universe is running downhill? Tell me in the comments what question followed you the longest. And tell me what you want to explore next. Black holes and lost information, quantum mechanics and whether time even exists, relativity and why now is different for everyone, or the mystery of why the universe began so ordered at all. If this kind of deep physics speaks to you, subscribe to the channel, not for the algorithm, but so we can keep exploring the questions that don't let us sleep. Thank you for giving this moment of your time. You can't rewind it, but you can choose what you do with the next one. I'll see you in the next video.